Welcome back. We are going to be focusing on solving a system of equations using the substitution method. This is a throwback to some algebra review, which we'll need for future lessons. While you are watching these notes, I encourage you to pause, try problems on your own, and then play. Or rewind if I've gone too fast. So don't you wish you could do that during the normal note-taking? But I don't have a pause button in real life. So the objective, we're going to solve a system of equations by substitution. And to remind you, a system of equations is a set of two or more equations containing two or more variables. For the most part, we're just going to see two equations with an x and a y. And a solution of a system is the ordered pair which works in both equations. If we're looking at a graph of the line y equals 2 and a graph of the line 2x minus 3y equals 6, where do these 2 points intersect? These 2 lines intersect at 6, 2. And when you plug in y is 2, that satisfies. And when we plug into the second equation, 2 times 6 is 12, 3 times 2 is 6, 12 minus 6 is 6. So this is the one solution that satisfies both equations. You may have been introduced to systems, most likely by graphing. We are going to do graphing later this semester. Substitution, that's what we're going to look at now. And then elimination or multiplication. That is the lesson for tomorrow. So, substitution is the replacement of value. Consider your favorite sports team. There can only be a limited number of people on the field or on the court. When one person comes in, someone else must leave. If you are going to replace the quarterback, a different quarterback must come into play. They might not look exactly the same, but they essentially serve the same function. In this case, our first example, I notice a nice substitution, a nice equality of two things, that y is worth the exact same as 5x. When I write my second equation, 2x plus 3y equals 34, in order to make that substitution, I'm going to take out the y, not the 3y, just the y, and in its place, I put the 5x. This is a single equation with one variable. I'm going to simplify my left-hand side. (2x plus 15x equals 34. 17x equals 34. When I divide both sides by 17, x equals 2. Now, when we solve a system, we are looking for a point. We're looking for an x and a y. Right now, all we have is the x. How do I find the y? I get to pick which equation to substitute my x in. It does not matter which equation you pick. I am going to pick the one that looks the easiest. Y equals negative 5x. And again, instead of writing x, I'm going to take the 2 and put it in place of x to get y equals 10. So the coordinates where these two lines intersect is 2, 10. The next problem is similar. I am going to look for an easy substitution. Here, I know what x is. X has a value of 2y plus 3. So it will be easy to do that substitution. When I write out 1 equals 4y minus x, I'm going to take out the x and in its place put 2y plus 3. Note, whenever I do a substitution, I will substitute with parentheses. That's a good habit to get into because you can see here we will be distributing that negative 1. So I will simplify my right-hand side, 4y minus 2y minus 3, or 2y minus 3 on the right-hand side. To solve, I will add 3 to both sides. 4 equals 2y. When we divide both sides by 2, y equals 2. So, as a part of my final answer, which is a coordinate, my y coordinate has a value of 2. Let's look at finding the x value. For my x value, I can choose either equation. I just think the first one looks a little easier. So y equals 2y plus 3. But this time, instead of y, I can substitute my 2. X equals 4 plus 3, which is 7. So the place where these two lines intersect is at 7, 2. Let's look at the next example. What happens when we have two x's that equal each other? This is a substitution again, but it might look a little strange. I am still going to substitute x equals y plus 10. So, in the other equation, which is x equals 2y plus 3, instead of x, I'm taking x out, and in its place, I'm going to write y plus 10. This is an equation that we can solve. I'll subtract y from both sides. I will subtract 3 from both sides to find that y equals 7. So as a part of my final answer, the y coordinate is 7. It does not matter which equation you use to find the next value. Let's try the first one. It does look a little easier. So instead of y, I am going to substitute 7, and x equals 17. So these two lines intersect at the point 17, 7. Let's take a pause here, and you can watch the next video to go through the last of these examples.